this video, I am going to show you how to solve the homogeneous differential equation. To solve this type of equation, the first step that we need to do is step number one, assume that y is equal to vx. So by assuming y is equal to vx, we can transfer this equation into a separable differential equation, then solve that equation in terms of v and x. And then the last step, we use v equal to y divided by x. We transfer the answer in terms of y and x. So the first step is to assume y is equal to vx. The second step, step number 2, is to solve in terms of v and x. Then the last step, step 3, we use v is equal to y over x, and we transfer the answer in terms of y and x. So let's go ahead and step number 1, y is equal to vx, then dy will be equal to v dx plus x dv. Now let's plug these values for y and dy in this equation. So if we do that, we are going to have 2x squared minus y squared, which is v squared x squared, dx minus x multiplied by y. Y is vx, so x multiplied by y is vx squared multiplied by dy, and our dy is v dx plus x dv equal to 0. So if we simplify that, we are going to have 2x squared minus v squared x squared dx minus v squared x squared dx minus v x cubed dv equal to 0. Now we can add these two terms together, so we are going to have 2x squared minus 2v squared x squared dx minus v x cubed dv is equal to 0. Now we have transferred this equation into a separable differential equation. So let's go ahead and rewrite this part as x squared times 2 minus 2v squared dx minus vx cubed dv is equal to 0. Now let's go ahead and divide. Let me write this equation here again. X squared times 2 minus 2v squared dx minus vx cubed dv equal to 0. So let's divide both sides of this equation by x cubed times 2 minus 2v squared. So if we do that, on this part, x squared divided by 1 over divided by x cubed will be 1 over x. This portion will cancel out. Dx minus x cubed will cancel out, minus v divided by 2 minus 2 v squared dv equal to 0. So let's go ahead and rewrite this portion as 1 over x dx plus v divided by 2v squared minus 2 dv is equal to 0. Now we can go ahead and take the integration of both sides of this equation. So we are going to have this portion, integration of 1 over x dx will be natural log of x plus integration of v over 2v squared minus 2 will be plus 1/4 natural log of 2v squared minus 2 is equal to a constant. So let's go ahead and multiply this equation by 4. So we are going to have 4 natural log of x plus natural log of 2v squared minus 2 equal to 4 multiplied by constant, which is again another constant. Now let's go ahead and write this part as natural log of x to power 4 plus natural log of 2v squared minus 2 equal to a constant. Now we can write this as natural log of x to power 4 multiplied by 2v squared minus 2 equal to the constant. So let's write this as e to power of that, e to power of c. So on left side we are going to have x to power 4 times 2v squared minus 2 equal to again a constant. Now we have finished step number 2, which we solved this problem in terms of v and x. So the last step, we use v equal to y over x from step number 1, our assumption, and we rewrite this as x to power 4 multiplied by 2v squared multiplied by 2. V squared is y squared over x squared minus 2 equal to constant. So here we are going to have 2x squared y squared minus 2x to power 4 equal to constant. Let's divide both sides of equation by 2, so we are going to have x squared y squared minus x to power 4 equal to c divided by 2, again constant. So this is our solution for this homogeneous differential equation. And I will solve another example of this type of equations in my next video, but I will wait a few days. If you have a request, if there is a problem that you want me to solve, please do not hesitate. I will solve it for you as soon as I get it. Thanks.